The moon, Earth's silent companion, shaping our tides and stabilizing our planet. But how did it form? A cosmic accident or something far more mysterious? The answer may rewrite everything we know about our world. The moon has fascinated humanity for millennia, lighting up the night sky, shaping tides, and inspiring myths. Yet, one of the greatest mysteries in science remains. Where did the moon come from? For centuries, scientists debated its origins. Some believed the moon was once part of Earth, thrown into space by our planet's rapid rotation. Others thought it was a wandering celestial body, captured by Earth's gravity. A third theory suggested that Earth and the moon formed together from the same cosmic dust. The rivalry between the US and the Soviet Union in the 1950s and 60s led to remarkable technological advancements. Satellites, computers, and even manned spaceflight. But perhaps its greatest legacy wasn't something humans created, but rather something they brought back: lunar rocks. On October 4th, 1957, the Soviet Union launched Sputnik 1, the first artificial satellite. This triggered a fierce competition. The Soviets continued to dominate space exploration, sending the first living creature, a dog named Laika, and later the first human, Yuri Gagarin, into orbit. In response, US President John Kennedy set an ambitious goal: to land a man on the moon before the end of the decade.
This nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
On July 20th, 1969, after a tense descent, Neil Armstrong and Buzz Aldrin successfully landed on the moon. Armstrong took his famous giant leap for mankind, marking a defining moment in human history. But their most significant achievement may have been what they brought back: lunar samples. Over 6 Apollo missions, astronauts collected 382 kilograms, 842 pounds, of moon rocks, providing the first real clues about the moon's true origins. One major discovery was the similarity between lunar rocks and Earth's crust. Scientists found that the moon shares the same oxygen isotopes as Earth, indicating a common origin. A groundbreaking new theory emerged: the giant impact hypothesis. Scientists believe that 4.5 billion years ago, in the chaotic early solar system, Earth collided with a Mars-sized planet called Theia. This cataclysmic impact ejected enormous amounts of debris into space, which eventually coalesced into the moon. Scientists discovered that the moon wasn't always a lifeless, frozen world. In its youth, intense volcanic activity reshaped its surface. Unlike Earth, where tectonic activity and water drive eruptions, the moon's volcanoes were fueled by impact-induced heat. For decades, scientists assumed the moon was completely dry. But in 2009, NASA's Lunar Crater Observation and Sensing Satellite mission changed everything. a spacecraft was deliberately crashed into a lunar crater, creating a massive debris plume. Spectral analysis of this cloud revealed something unexpected: water ice. The Cold War space race is over, but a new lunar competition has begun. Nations like the United States, Russia, China, India, and Japan are preparing missions to explore the moon's resources. NASA's Artemis program aims to establish a permanent lunar base, while private companies like SpaceX and Blue Origin plan to mine the moon's valuable minerals. The more we learn about the moon's origins, the more we uncover about Earth's own history. Once a symbol of Cold War rivalry, the moon is now the key to humanity's future beyond Earth. One thing is certain: the moon's story is far from over.